Now, once again, a very popular trend, the popular trend of combining two concepts. And in this question, if you see, which is on the screen, the amalgamation is of quadratic along with the trigonometry. All right, that two trigonometric ratio entities, basic simple examples. Now, let's quickly read the question. Let alpha and beta are two real roots of the equation. Perfect. K plus 1 tan square x minus root 2 lambda tan x equal to 1 minus k, where k not equal to minus 1 and lambda are real numbers. If tan square alpha plus beta is given equal to 50, then the value of lambda is. See, they've given you that for the given quadratic equation has roots as alpha and beta. That is, the tan alpha and tan beta are eventually the roots of that equation because the quadratic is in the variable tan x. Right, and if alpha is satisfying that, then tan alpha and tan beta will become its roots. So I can have the sum of roots and I can have the product of roots, which I can easily plug in the value of the formula, or rather values in the formula, tan of alpha plus beta. The moment you put it, you simplify, you get the answer. Pretty simple one. Okay, I quickly repeat. From the first quadratic, the roots will be tan alpha and tan beta, right? Get the sum of the root, get the product of the roots, plug into the formula of tan of alpha plus beta. You know the formula, tan alpha plus tan beta upon 1 minus tan alpha tan beta. Quick revision. Plug in the value, simplify, you get the answer. All right, so if you wouldn't have got it earlier, doesn't matter. Please solve it now once again quickly to reach to the answer. All right, now I am anyhow going to solve it. Don't worry much about it. Okay, so let's quickly begin the solution. So this is what my given information, the given quadratic, right? And alpha and beta are the roots of this equation. And the expression tan square alpha plus beta is given to me as 50. Perfect. So I can say that if alpha and beta are the roots of that equation, that is tan alpha and tan beta are roots of nothing but this equation, right? And from this equation, if I can say that this particular equation only, if I can infer this as that tan alpha and tan beta are the roots of this equation, I can find the sum of roots and the product of roots. Sum of roots from this equation can easily be figured out as root 2 lambda divided by k plus 1. And as similarly, the product of roots can be defined from here as k minus 1 over k plus 1. Sorted? Okay, wow. So I have the value for tan alpha plus tan beta, and I have the value for tan alpha into tan beta. And the given relation is tan square alpha plus beta equal to 50. So let's quickly apply the formula for tan of alpha plus beta. What was the formula for tan alpha plus beta? Can you see this? Tan alpha plus tan beta upon 1 minus tan alpha tan beta. See, the sum of roots and the product of roots will be actually utilized here. So if I try to plug in the value here, so this value 50 will become is equal to, so numerator will become what? Tan alpha plus tan beta, which is nothing but sum of roots. So we get this as root 2 lambda divided by k plus 1 whole divided by 1 minus product of roots, which is k minus 1 over k plus 1 and the whole square of it, because tan square alpha plus beta is equal to 50. Be very careful by the calculation. All right. Okay, good. So let's quickly simplify. What do we get here? We get this as root 2 lambda divided by k plus 1 in the numerator. I'm not disturbing that. The denominator is nothing but k plus 1 minus k plus 1 divided by k plus 1. Right, I'm putting the brackets once again now as in whole. So this in the denominator k and k got cancelled. And can you see that k plus 1 and k plus 1 is also getting cancelled? What do I have it here now? Right, what exactly I'm left with? I'm simply left with the expression of root 2 lambda square divided by 2. Rather, in fact, I'll put it up in this way. We get this as root 2 lambda divided by 2 the whole square. And this value is given to me as 50. Right, this value is given to me as 50. So what can I infer from here? See, root 2 lambda by 2 is nothing but lambda by root 2, and its square will become what? Lambda square by 2. Lambda square by 2 equal to 50. What does that imply? Lambda square equal to 100. And if I have lambda square equal to 100, what do I get the value for lambda is? Lambda becomes nothing but equal to plus minus 10. Right? Calculation is very simple. It's just that you have to understand that alpha and beta are the roots of that equation. So in place of x, I'll be putting alpha and beta. So my quadratic is basically in the variable tan x. So if I plug in alpha, I'm actually getting the value for tan alpha as a root and tan beta as a root. Hence, I have tan alpha and tan beta are roots of this equation. From there, I got sum of roots, I got product of roots, I plugged it into the formula of tan of alpha plus beta. Then it's a simple algebraic calculation where your accuracy will matter a lot along with speed. So once you simplify it quickly, you get this as lambda square equal to 100, or you get lambda equal to plus minus 10. Sorted? Pretty simple one. Okay. So from here, we say that the option C is the correct answer among the given options. All right. I hope this is pretty simple for everyone. please be very careful that we have made a square over there, right? So tan square alpha plus beta was equal to 50, right? So when you're plugging in the values, be very careful while inputting the values. I hope this is sorted for everyone. Now get ready with this question. The question says that system of linear equation, chapter determinants. So if the system of linear equation, you can in fact say the matrix also, because we solve the simultaneous equation or this system of linear equation with the help of matrix also. All right, so either refer to that Cramer's rule or you refer to the matrix method. Either of them, both of them are fine. Okay, I'll pick up the method for determinant, which is quite simple to handle. Cramer's rule is very popular also. Okay, so if the system of linear equations, these three equations are given to me, can you see that the constant in both all the three equations on the right side is 0? Do you remember the name of such equations? The name of such equation was nothing but homogeneous equations. Right, so I have a system of homogeneous equation, and if a system of homogeneous equation is there, one thing is pretty sure, that whatever these equations are there, at least one solution will be there. And what is that? Origin 0, 0, 0. Check it out, you just plug in the values. So 0, 0, 0 will satisfy the first, the second and the third, all the three equations for sure. All right, okay, so one solution is definitely there. Now, I have two types of solution in the case of homogeneous equations. What are the two types of solution that we have here? First one is that we have either a unique trivial solution. So unique trivial is nothing but the solution which I talked about, 0, 0, 0. Trivial stands for 0, right? Okay, and the second category is that we have infinitely many non-zero solution or non-trivial solution. You call it non-trivial or non-zero, doesn't matter. Only two types of categories. So these homogeneous system of equation can have only two types of solution. Either it will have only a unique trivial solution, that is 0, 0, 0, or you can have them other type of solution as infinitely many non-zero solutions along with 0, 0, 0. So are you getting my point, what I'm trying to say here? Just keep that in mind. The moment you see homogeneous equation, this fact should flash in your mind, right? Only two types of solution. One, unique trivial 0, 0, 0, or infinitely many non-zero solutions as well. Okay, so let's read the question now. So I have three equations which are homogeneous. Now it says that the coefficient are real number and non-zero. And this equation has non-zero solution. Which category? Infinitely many solutions. And if I have infinitely many solutions, what was the concept? That the determinant formed by the coefficients becomes equal to 0. Exactly. See, when we have unique trivial solution, this is the case when the determinant formed by their coefficients is non-zero. And when we have infinitely many trivial solution, the determinant formed by their coefficients is 0. Understood the idea? So very crystal clear cases. Homogeneous equation, only two possibilities. First one, we can have unique trivial solution. For that, coefficient determinant will become not equal to 0. And if I have a non-zero infinitely many solutions, then we'll have coefficient of determinant, or rather determinant formed by their coefficients is equal to 0. Perfect. All right. So now if you want to give it a try, please start solving it very quickly. Try to report the answer before me. All right. But everyone else, you can refer to the screen and watch the entire solution. Guys, I'm solving the calculation now. So these are my three homogeneous equations. As I said, the determinant formed by their coefficient will become equal to 0 because we have non-zero solution, and non-zero solution will only occur in the case of infinitely many solutions. And for that, coefficient determinant has to become equal to 0. So let's form the coefficient determinant. What is the coefficient determinant? So in the first, x coefficients are 2, 2, 2. Second one, we have 2a, 3b and 4c, and then we have a, b, c. Can you see the coefficients? So my coefficient determinant will become somewhat like this. So first column becomes the coefficient of x, which are 2, 2, 2. Second column is coefficient of y, which are 2a, 3b, 4c. And the third column is a, b and c, which are nothing but the coefficient of z. Perfect. I know that this value has to become equal to 0. Now, I have to infer a relation in ABC, right? When I read the quickly the options and all. So what were my options, by the way? My options were simply these, right? So my options were either a plus b plus c equal to 0, or a, b, c are in AP, or 1 upon a, 1 upon b, 1 upon c are in AP, or a, b, c are in GP, right? So I just have to figure it out. So I'll quickly move on to my calculation part. Now, in order to solve it, you just try to pick up the hint, right? And I'm sure you must have been familiar with. So I'm making you a one standard way of working for you in case if you're not aware of it. Can you see the element in the first column are all identical? And if you have to find the determinant for this, first method is you open it up. Do not think anything, just quickly open it up. Without thinking anything, just quickly open it up and then simplify. First method. Second method is try to shorten the calculation. And how would you be doing that? See, if all the elements of first column are equal, then I can do one thing here. I can subtract the elements of row 1 from row 3, and I can subtract the elements of row 2 from row 1. Are you getting my point, what I'm trying to say? So I'm modifying row 2 and row 3 by subtracting the elements of R1, row 1 in both of them. Advantage, the first element will become 2 minus 2, 0 in the second row, as well as in the third row, it will also become 2 minus 2 as 0. This is what the advantage, right? We got 2 zeros in the first column. We'll expand the determinant with respect to first column. Now, would you like to try? Please go ahead. These are the two transformations which I would like to do. R2 goes to R2 minus R1 and R3 goes to R3 minus R1. Okay, so what do I get it here by doing this? Please look at the screen carefully. So the first row is not changing. So that is my reference row and that will remain intact. I'm not supposed to touch it. Perfect. Okay. So let's quickly pick it up. So what do I have it here? When I'm doing R2 minus R1. So 2 minus 2 makes it 0. 3b minus 2a as the second element. And the third element is b minus a. Similarly, for R3 minus R1, 2 minus 2 makes it 0. 4c minus 2a is the second element. And c minus a as the third element. Can you see that? Now, once you have the two elements as 0, what will you do? You'll just open it up. Let's quickly open it up now. With respect to what? First column. Because the first column will involve only one element, that is 2, right? So you just have to open it up. So we get 2 times of what is the minor determinant that I got here. We got the, see, for 2, I'm doing this this hypothetical thing. I hope people are aware of it. So if I have to expand with respect to 2, we remove this row and this column and this row. So we remove this row, we remove this row. What I'm left with? I'm left with this subdeterminant, right? Okay, or minor. So we call this as minor. This is nothing but 2 times of 3b minus 2a, 4c minus 2a, and then b minus a, c minus a equal to 0. Right? Sure? Okay, so let's quickly open it up. Let's say, so it's just a simple cross multiplication. We get 2 times of 3b minus 2a into c minus a minus of 4c minus 2a into b minus a. This will become equal to 0. Is it sorted for everyone? I hope this is clear for everyone. Okay, perfect. So this is equal to 0. All right. Now, if I do this calculation further and open it up, my calculation will look somewhat like this. I'm removing this so that you can look at it carefully. Okay, people are comfortable with it. Okay, so I'm left with this calculation. Now, calculation is very simple. You just have to open it up, right? This 2, of course, will get cancelled here. So I don't have to even write it here also, right? This really not needed. Okay. Now, when the product, if you take the first 2 products will give me these 4 terms. The second product will give me these 4 terms. Right. Okay. So let's open up and simplify. What do I have it here? So we got 3bc minus 4bc will give me minus of b into c. Minus 2ac plus 4ac will give me plus of 2ac. And minus 3ab plus 2ab will give me minus of ab. And plus 2a square minus 2a square will get cancelled. This equal to 0. Very simple to handle actually. So what do I got it here? I have 2ac is equal to ab plus bc. Let's quickly divide by abc. So when I divide the entire equation by ABC, we get this divided by ABC, this also divided by ABC, this also divided by ABC. Simplify, BC got cancelled, A into B got cancelled, and here A into C got cancelled. So what do I have? I have 2 by B equal to 1 upon C plus 1 upon A. What do you call this? 2 by B equal to 1 upon C plus 1 upon A. This is nothing but the relation when I have 1 upon A, 1 upon B, and 1 upon C are in AP. Did you understand the idea? So the key takeaway for this question, was if you have homogeneous equation, there are only 2 types of solution in this. First one is unique trivial. For that, coefficient determinant becomes not equal to 0. Or you can have infinitely many solutions. For that, coefficient determinant will become equal to 0. And that's what we have done here because we have non-zero solutions here. Right? Okay, and then the moment when I made this coefficient determinant equal to 0, from there after simplifying the result, we got to this. I've given you one trick for simplifying the determinant also, that if all the elements of a certain row, or certain column are equal, try to subtract those 2 rows so that 2 elements of that, let's say if this is 3 by 3, then 2 elements of them will become 0 so that we can expand it with respect to that particular row or that particular column. It will actually save your time in the examination hall for the calculation purpose. All right. Everyone, lovely. Let's quickly move on to it. Okay, so I hope both the key takeaways of system of homogeneous equations their solutions and the determinant trick, both of them are intact with you and you are going to use it in the future examinations, right? Now, please read this question. The question says that let x raised to k plus y raised to k equal to a raised to k, a comma k greater than 0. And some relation is given for dy by dx plus y by x raised to 1 by 3 equal to 0. Then they're asking the following value of k. One concept, differentiation, simple adjustment. See, please try to grab these questions and always be very much sure that you make no mistake, not even a slightest of mistake in such questions. These are freebies, guys. In the examination of mains and all, these questions are freebies. These are like they are distributing marks for free. You just have to pick them up. Be extremely careful about such questions. If you get a question of this sort, you make sure that you get it very quickly and correctly also. All right. So there is only one thing. Just simply differentiate and get the answer. All right. So let me quickly start the solution. So my original given relations are x raised to k plus y raised to k equal to a raised to k. And the derivative relation, which was dy by dx plus y by x raised to 1 by 3 equal to 0. So what do I have to do? I have to infer the value of k from here. All right, so if I have to infer the value of k from here, what do I need to do? I just have to figure out dy by dx from the given equation. So what do I have the given equation as? So my given equation is nothing but x raised to k plus y raised to k equal to a raised to k. Let's differentiate. So when I differentiate with respect to x, we get this as k times of x raised to k minus 1 plus k times of y raised to k minus 1 into dy by dx is equal to derivative of a raised to k, which is a constant, will become 0. Simple. Okay, now I have to make dy by dx as a subject, right? You see that dy by dx plus of something equal to 0. So I have to adjust in that way. Let's do the adjustment. So k and k got cancelled from this equation. So I can say that dy by dx, rather y into k to the power minus 1 into dy by dx is equal to minus of x raised to k minus 1. Right? I can take that y raised to k minus 1 on that side. So I can write this as dy by dx is equal to minus of x raised to k minus 1 divided by y raised to k minus 1. Okay, let's rewrite it and bring that entire bracket thing on the left side. So what do I got it here? I got this here as dy by dx plus of x by y raised to k minus 1 equal to 0. Okay. But the thing is, the relation which is given to me, it contains as dy by dx plus y by x. So I have to create that one only. So let's modify this, please. This is dy by dx plus y by x raised to 1 minus k. The power will become just minus times of that equal to 0. Now, please look for this particular relation carefully. This one. Okay, so let's look for this relation carefully and compare it with this relation here. What do I have it here? We have dy by dx in both of them. Yes. Plus, yes. Y by x, yes. The exponent in one case is 1 by 3, in the other case it is k minus 1. Oh. So in one case it is 1 by 3, other case it is k minus 1. What does that imply? It simply implies that the value for k minus 1 here is nothing but equal to what? 1 by 3, right? And from here I can say, sorry, the exponent will become 1 minus k. It will become, power will become minus times of that, right? So that's a mistake which I have done. I'm extremely sorry for that. Okay, so when I do the comparison, I'll get this as 1 minus k equal to 1 by 3, which implies that k become equal to what? 2 by 3. Are you getting comfortable with this? So I hope that correction you must have observed. So see, I had this x by y raised to k minus 1, but I have to get the format for y by x. So the moment when I flip x and y, I reciprocate them, I need to make the power as minus times. So that is nothing but minus of k minus 1. And what is minus of k minus 1? That is nothing but y by x raised to 1 minus k. Alright, and this power 1 minus k is given as 1 by 3, which I equated to 1 minus k as equal to 1 by 3. I get k equal to 2 by 3. Right, so I can report this k as 2 by 3 as my answer. Sorted? Sure? Perfect. So from here, I would say that the option C is the correct answer. As I said, these are freebies, guys. You just have to be very careful about the calculation and that too, the accuracy. Speed along is something which you have to inculcate in that way. All right, sure, understood? Now everyone please read this question carefully because you have to make many judgments before solving this question. And in all such questions, the thought process has to be extremely streamlined and well connected. Okay, so read this question carefully and read it with me. Let the function f such that close interval minus 7 to 0 and from minus 7 to 0 to r be continuous on this close interval and differentiable on open interval. Okay, so they're asking me to be this expression, or rather this function f, to be continuous in the closed interval of -7 to 0, but differentiable in the open interval of -7 to 0. Have you read something of that sort? That some function f is continuous in the closed interval and differentiable in the open interval? Have you read it somewhere? Please stress a bit more on your head. Something that you studied anywhere? Yes. Application of derivative, the concept of LMVT or Rolle's theorem. Right. Both of them enter these things. Both of them. And this is a key takeaway, right? This is a quick hint. See, the question cannot be in the much easier language. They have given you exact thing that the moment you read that thing, that statement, that continues in the closed interval and differentiable in the open interval, immediately this should flash into your mind that it has to be either a case of LMVT or Rolle's theorem or any of those theorems which you know. Right? Okay, so just they keep this thing into your mind. Now read the question further. So I hope you remember the statement precisely for Rolle's theorem, right? So we say that between two roots of any function or any expression, they rely one root of f dash x equal to 0, right? But let's see what this question says. They say that now if f of -7 equal to -3 and f dash x less than or equal to, so they have given me some value for f dash x less than or equal to 2. See, had it been the value that Rolle's theorem is there, that between two real roots of fx, we have one real root of f dash x, at least one root of f dash x is equal to 0, right? They're not talking about f dash x is equal to 0. They're assigning a value of f dash x less than or equal to 2, which clearly imply this is not going to be applied here. Strictly, I will be moving around LMVT. Why? Because Lagrange's mean value theorem clearly state you about the slope of the tangent of that curve, which is having its initial point between a and b, or that particular interval in which the function is continuous and differentiable in the respective closed and open intervals. Did you get the idea? So I have the relation for f dash c, right? And see, I have f of -7, okay, and I'll be taking the help of f dash x less than or equal to 2. Based upon that, I have to predict the value of f of -1 and f of 0. So that's why they're saying that f of -1 and f of 0 will lie in certain interval. Why? See, if f dash c or f dash x is less than or equal to 2, so from here, if I am predicting the value of f of b or f of b, it has to be in terms of an inequality, right? So f of -1 or f of 0, whatever that I'm going to predict from here, from this particular case, they have to be in the inequality format. That's why this sum, f of -1 plus f of 0, will actually give me an answer in the interval format. Take the quick look on the intervals. -6 to 20, close interval. The second one, -infinity to 20, close interval. -infinity to 11, close interval. And -3 to 11, close interval. Okay, so just keep this option in your mind and we'll start with the calculation. For sure, one thing we have assured, that how LMVT is going to apply it into this, right? And why LMVT is going to apply it, and how you should think about it, right? If I would have been a student, I would have thought exactly in the same fashion. The moment I'll pick up the hint that continuous in the closed interval and differentiable in the open interval, and then they are talking about the derivative, oh my god, there's only one way. What do you have to do? Lagrange's mean value theorem, right? Guys, quickly start with that statement. So I'll start with the given information. So I do have f of -7 equal to -3 and f dash x less than or equal to 2. And the interval which is given to me is closed interval -7 to 0 for continuity and differentiability in the open interval -7 to 0. So one thing is pretty sure that I can apply my Lagrange's mean value theorem in that interval of -7 to 0, right? So I can choose a and b as -7 and 0. Are you getting my point, right? Perfect. So I know that the formula says that f dash c will become is equal to f of b minus f of b a whole divided by b minus a if this f is clearly continuous in closed interval a to b and f is differentiable in open interval a to b, right? So now I have to predict f of 0. F of -7 is given, so what will I do? I'll apply my logic in that way only. So let's quickly apply the Lagrange's mean value theorem in the closed interval of -7 to 0, right? So I'm writing this statement for you. Please look at it carefully. That's neatly written. So if I choose b as -7 and a as 0, doesn't matter which one is smaller or which one is larger, it really doesn't matter. So we have f of -7 minus f of 0 divided by -7 minus 0. So precisely it should be -7 minus 0, but it doesn't mean anything. That's why I've kept it -7 only. And this is nothing but equal to the derivative f dash c. Now, can you see this less than or equal to 2? You must be wondering how this is coming. See, the entire derivative f dash x in general is less than or equal to 2. So if I'm taking it for a certain c, that also has to be what? Less than or equal to 2 only, right? And because of that only we are able to make a judgment upon which value? F of 0. Why? Because f of minus 7 is already known to me beforehand. Lovely, right? So let's quickly start my calculation. How am I putting into it? Or if you want to put me, I'll quickly say that f dash c here will become equal to f of minus 7 minus f of 0 divided by minus 7 minus 0, right? But since this f dash c is less than or equal to 2, hence I will be making this entire quantity also as less than or equal to 2. Got the idea? Let me start the calculation quickly now. So I do have f of minus 7 minus f of 0. Okay, I'll plug in the value of f of minus 7 also, which is nothing but minus 3 here. So minus 3 minus f of 0 divided by minus 7 is less than or equal to 2, right? I hope you get my point. So I can multiply minus 7 on the right side and I'll be changing the sign of the inequality, right? So let's change the sign of the inequality quickly. So I got this minus 3 minus f of 0 greater than or equal to 2 into minus 7, which is minus 14. I'll take that f0 on that side, the right side, and I'll take minus 14 on the left hand side. So we get this minus 14 will come here as plus 14 minus plus of minus 3, or let me put it up in this way. So we get minus 3 plus 14 greater than or equal to f of 0. Okay, so what do I have it here? I can say from here that f of 0 is nothing but less than or equal to 11. This is the first conclusion that we have derived from here. Right, okay. So I'll say that this minus 3 plus 14 is less than or equal to, greater than or equal to f of 0, or in other words, f of 0 is less than or equal to 11. Sorted? So f of 0, I have made a judgment. Now I have to make the another judgment on f of minus 1. What will I do? For that purpose, I'll again apply the LMVT on f of minus 1 and f of minus 7. Got the idea? Perfect. So let's quickly apply again LMVT now in the closed interval of minus 7 to minus 1. Now you must be remembering, sir, can I apply it in that interval? See, if an expression or if a function is continuous in minus 7 to 0, will it also be continuous in minus 7 to minus 1? Of course it would be. Of course it would be. So I can definitely apply my Lagrange's mean value theorem in this interval also, right? Hence I am choosing this interval intentionally, as I could comment upon the value of what? F of minus 1. So the moment when I apply my Lagrange's mean value theorem, this statement will pop up, right? So we got, if you want me to write once again, let's see, this is f dash c is equal to f of minus 7 minus f of minus 1 divided by minus 7 minus of minus 1, and this quantity has to be less than or equal to 2. That eventually have reached there. Now let me quickly solve it for you. So I got this as f of minus 7 as nothing but minus 3 minus f of minus 1, I'll keep it as it is because I have to comment on that value, divide by minus 6 less than or equal to 2. Once again, I can multiply by minus 6 on the right side of the inequality, but the sign of the inequality will definitely change as I'm multiplying by a negative number, right? So from here, when I multiply by minus 6 on that side, or let's say if I keep that minus sign, I'll multiply the minus sign in the numerator. I'll dissolve it in the numerator. So what will I have? I'll have f of minus 1 minus of minus 3, right? And that will become less than or equal to what? 12, because I've taken only 6. Minus 1 I've dissolved in the numerator. Understood? See that there I've shown you that calculation. So here I'm showing you another calculation, another type of calculation. Perfect. I can take that minus 3 on that side. So I can say that f of minus 1 is less than or equal to what? 12. Minus 9 will become plus of minus 3 basically. So minus of minus 3 is nothing but plus, right? Which will become here as minus, if you want me to put it in that way. So 12 minus 3 or nothing but 9. So I can say that my f of minus 1 will become nothing but equal to less than or equal to 9. Now what do I have? f0 less than or equal to 11 and f of minus 1 less than or equal to 9. Okay. So f of minus 1 less than or equal to 9 and f of 0 less than or equal to 11. If I add the LHS and the RHS, right, lower with the lower side, larger with the larger side, it's not going to affect the inequality. So adding the LHS, we get f of 0 plus f of minus 1. RHS will give me 20. So the sum of f0 plus f of minus 1 is less than or equal to 20. Hence, the option B will become the correct answer. Got the idea? The key takeaway for this question is you have to get the hint by reading the statement of the question, that if they are giving me some function continuous in a closed interval and differentiable in an open interval, then I have to think about the theorems which you have studied in the chapter of application of derivative, that is either Rolle's theorem or Lagrange's mean value theorem. Now, since they have put a certain condition on f dash x less than or equal to 2, which implies that I have to apply the Lagrange's mean value theorem. All right. Then you simply adjust the data and see we have to comment on f of -1 and f of 0. So once I'll be applying LMVT in the closed interval of -7 to 0, and then I'll be applying the LMVT in the closed interval of -7 to -1, because I have to comment on the value of f of -1 also. All right, sorted. Pretty good question to observe. Lot of good key takeaways and very sharp insights that just by reading that statement, few things should immediately pop up in your mind. Otherwise, it will be difficult for you to make a thought about this problem. So from now onwards, guys, it is sorted. The moment you read this statement, immediately the concept of LMVT or rules should flash into your mind. All right. Now everyone, please read this question carefully. You must have guessed the chapter, as this statement is already including the name differential equation. So the concept is a differential equation, and there's only one chapter and only one concept is associated to it. So question is really easy. And of course, this is part of the freebies that you get in every paper. Trust me, this is really a freebie. So you have to make sure that you are very quick and accurate in getting the answers, right? And you have to get to the answer. Okay, so if you're not being able to solve it, please quickly refer to the solution, that what we are solving it here. Let's take up the thought. So if y equal to yx is the solution, so y equal to yx, so instead of fx, they have just named it y equal to yx, right? Okay, so that's how they are putting it out. Is the solution of the differential equation, so the statement for differential equation is given to me, you have to mark it, such that y0 equal to 0. I'll tell you one thing very quickly. See, if they say y0 equal to 0, it clearly implies that at x equal to 0, we get y equal to 0. That is, it is passing through origin. Or the point 0, 0 in terms of x, y will satisfy this curve. See, differential equation is not, is what? Nothing but it's a family, or rather I won't say family. In fact, I will say that differential equation is nothing but the equation of a curve written in a different way, right? Written in differentials, but it's a curve only, right? It's always a curve. So represented in the differential format. So it's a family because we keep on changing the variables, right? We have if I keep the general variable c, it will be family. Here, this give me one precise value, y0 equal to 0, which means it has to be a fixed curve. So in nutshell, I'll say that if I have a differential equation, that will represent a curve. So this curve has to pass through origin if y0 equal to 0. Consider this case. Let's say if I have y1 equal to k, then can you tell me what does it mean? It clearly means that it passes through the point 1, k. Exactly. That's what I have to tell you. Right? Understood? Perfect. Okay. So without any further ado, let's quickly get started with the calculation part. There's nothing else that you have to do. You have to solve the differential equation. There's no way out. So what do I have it here with the given information? The given information is e power y dy by dx minus 1 equal to e raised to x and y0 equal to 0. Right? So y0 equal to 0, it means that it passes through origin that I've already sorted. So let's quickly see how does it look. So if I modify it, if I take that e power y on the other side, we have dy by dx minus 1 is equal to e raised to x upon e raised to y, which is nothing but is equal to dy by dx minus 1 is equal to e raised to x minus y. So if I take that 1 on that side, my differential equation will look like dy by dx is equal to 1 plus e raised to x minus y. Now in all such questions, the trouble is basically lying because I have x minus y in the linear format. If I can get rid of this x minus y, then I'm done. Right? dy by dx is sorted, 1 is sorted. So this x minus y in the linear format is disturbing me. Can I convert it into one variable? How will I do that? Substitution. Put x minus y as t. The moment you have x minus y as t, if you differentiate this relation x minus y as t, you get 1 minus dy by dx equal to dt by dx. Right, let's quickly plug in these two values into this equation. Right, so I'll be putting these two values into this equation. What do I have the modification here as? The modification here after putting these values will become equal to dy by dx I can replace. So dy by dx I can replace it as 1 minus dt by dx. Right, and that will become equal to 1 plus e raised to t. Okay, wow. So if I get this 1 plus e raised to t, so 1 minus dt by dx is equal to 1 plus e raised to t. So this 1 and 1 will get cancelled. What do I have it here? A very simple calculation that is following here. We get this as minus dt by dx is equal to e raised to t, which implies that we get this dt is equal to dt by e raised to t is equal to dx, right? Okay, and with a, let's say I'll put a minus sign here, integral. So dt by e raised to t is nothing but what? E raised to minus t dt is what? Simply e raised to minus t with another minus sign. So minus of e raised to minus t is equal to minus of x plus c. I'll remove that minus sign here, right? It's a simple thing to handle. So what do I got it here? So if I try to modify this expression, this will look to me as, so let's plug in the value of x and y. So e raised to minus c, that is e raised to minus of x minus y is equal to x plus c. Okay, which implies that e raised to y minus x is equal to x plus c. Wow, this is what my answer. E raised to y minus x is equal to x plus c. Perfect. Very simple calculation and very quick one. Now, the challenge is now for this value c. Why? Because I have to figure out the value of c, and then they have asked me the value of y1. That is at x equal to 1, what will be the value of y? Right? Perfect? Okay. So since they are asking me the value of y1, which is at x equal to 1, what is the value of y? I have to first figure out the value of c. And I know that this curve surely passes through origin, 0, 0. So I'll take the advantage of that, right? And now I'll be satisfying this curve by origin. So the moment when I satisfy origin into this equation, what do I got? I'll put x equal to 0 and y equal to 0. We got e power 0 equal to c. If I have e power 0 equal to c, what does that imply? C equal to 1. And if c is equal to 1, what do I got? I got e power y minus x, basically. So I'll be getting this equation as the final curve, right? So this is what my final curve. What is my question now? They are asking that what is y1? Which implies that what is, so basically they are asking that at x equal to 1, what is the value of y, right? For that matter, what will I do? I'll just plug in the value of x equal to 1. So at x equal to 1, how will it become? It will become e to the power y minus 1 is equal to 2, right? From here I can say that y minus 1 is equal to log 2 to the base e. So y will become is equal to what? Y will simply become is equal to 1 plus log 2 to the base e, right? Hence, y is equal to 1 plus log 2 to the base e will become my answer. See, this question was a pretty easy cakewalk, right? A very simple calculation for solving differential equation. Then, if y0 equal to 0, which means that the curve is passing through 0, 0, and after that I have to figure out the value of c, because that c is always associated with the differential equation. It's an integration constant, right? Okay. Since it's an indefinite integration, so I have to put that. And then I have satisfied origin into that. Fortunately, I got value of c equal to 1. My curve equation becomes modified to this. And then I know that they're asking the value of y1. That is at x equal to 1. What is the value of y? So I'll plug in the value of x equal to 1 into this given curve. When I plug in the value, we got e power y minus 1 equal to 2. Sorted it out. We got y equal to 1 plus 2 log base e. Sorry, y equal to 1 plus log 2 to the base e. Understood it? Sorted, right? So the key takeaway for this question is that if they're asking for y0 equal to 0, it clearly implies that the curve is passing through 0, 0. If they are saying that y lambda is equal to mu, it implies that the curve is passing through lambda, mu. Differential equation solving is an easy cake, so you know how to handle it. All right.